last reaction that we're going to see in this chapter is called Robinson annulation. He won the Nobel Prize in 1947, famous British chemist. So it is a Michael addition followed by an Aldol condensation. So I want to look at an example with you guys of this, and we'll see that Michael addition example reaction also in the course of this reaction. So let's take a look at this. Let's look at this reactant. And let's predict what would happen here if we added sodium hydroxide and methyl vinyl ketone. So the question is, what product is formed here? So this is one of those things where it's not like an SN2 where you can just write it out. You're going to have to work through this. So let's do that down below. So let's take a look here at the mechanism of this thing. Okay. All right, so of course we got to start off with our reactant. So take a second and let's draw it out. So first step here is that we have sodium hydroxide. So NaOH, you got hydroxide floating around in solution there. Okay, so we are going to first deprotonate at this bottom position. So we're going to swing around here and we're going to grab one of those H's. Okay, what that's going to give us here is an enolate. So minus charge there. And then I'll just write down here, of course, plus resonance. So we don't have to draw it out, but it's in there, right? All right, so here's your enolate. Now remember, enolates add in a 1,4 addition when we do that Michael addition. So let's get our methyl vinyl ketone in here. Okay. Now with that methyl vinyl ketone, remember our numbering? 1, 2, 3, 4. So what we want to do is we want to come around here just like so and react at that carbon right there. And then we're going to shift those electrons around to right here and then swing them over here to our oxygen atom at the end. Okay, so next task, draw that out. All right, so here's our new bond right here. Okay, so our new bond is connected to 1, 2, 3, 4. So 1, 2, 3, right? 4, 1, 2, 3, 4. We got 4 bonds in total here. So what we need to have on here, right? This is our carbon number 4 essentially right here. Here's your number 3. Here's your number 2. Here's your number 1. Number 2 is where the carbonyl is. So that's going to be an oxygen now with a minus charge there. Right? And then our double bond here is going to be between 3 and 2, right? So our double bond goes right there. Okay. So what we're going to do next here is we're going to go through and kind of do our cleanup phase. So we have sodium hydroxide in the presence of water. So we're going to swing around and we're going to basically grab an H. We could either protonate that oxygen as it stands right there and then do a keton-enol reaction, or we could skip a step and we could just do this. So I'm going to do that so that I don't have to draw that out. All right, so let's draw out what our product of that reaction is. So again now, right, 1, 2, 3, 4. 3 aligns it. 4. Okay, so we're coming over here and we now have this. Okay, so that was our Michael addition there. Those are Michael additions. So what we want to do now is we want to think about what can occur. So remember, you are in a solution of sodium hydroxide. So we have hydroxide in solution right now. So let's think about doing an intramolecular aldol condensation. Remember, our targets for doing that, our target for a cyclic structure should be 5, 6, 7 membered ring. So if we look at this thing, and let's number it. Let's number that as number 1, 2, 3, 4, 5, 6. So this is a CH3 here. If we could have that be our enolate negative charge, that number 6 could react with number 1, and we form a nice little ring there. So let's do that. Swing around and grab this H, and what that's going to give us is our structure, our original template, and now with our oxygen CH2 minus charge here. Okay, and now what's going to happen is that's going to swing around now. It's going to swing around and it's going to react to that carbon number 1. So we're going to swing this guy around here, and we're going to do this and then that. Alright, so our next goal, how do we draw that? It's going to be kind of a mess. Well, let's don't worry about that ring, but let's draw everything out in our skeleton first. So original skeleton looks like this. Now we know that this carbon right here is that carbonyl, so we can at least write an oxygen there with a minus charge. We also know this: 1, 2, 3, 4, 5, 6. So we know we have a 6-membered ring there, so we can draw a ring. So that ring is going to look like that. Well, let's number 1, right? 1, 2, 3, 4, 5, 6. Okay, so we got the ring, got that figured out. Now, where do we put the carbonyl? Carbonyl's at number 5. So the carbonyl is right here. And there we have it. So that's all we really had to do there. Now we're not done. So we're going to continue on with this reaction. We're going to protonate that oxygen up there at the top with water. So we're going to come over and grab a hold of that H just like so. So redraw this guy here, and put an OH right there. Okay, now with a little bit of a push, right, maybe perhaps some heat involved here, we could do a dehydration also. And so dehydration, well, you grab one of those H's, right? So we're going to swing around here, grab an H, and again that's going to give us this big old mess of a molecule. Plus resonance. And then finally, that last step, we'll do our dehydration there. Right, so swinging around here and doing that just to draw that out a little bit better. And that gives us this. So that's your final product there. So this is what we want to draw up in that space that we see up above. So now again, kind of a long reaction, but it contains things that we've seen throughout this chapter. So as long as we're good with those old reactions, then this one isn't too much of a stretch, other than the fact that the molecule is kind of large and, you know, a little bit more complex than most of the products that we've drawn up to this point.